In this video, I'm going to show you how to implement the Excel solver model for the transportation problem. So just a very brief review of this problem. In this basic transportation problem, we have some citrus available at 3 groves listed here in this table. And we're going to ship them to 3 processing plants based on the least citrus miles. And this table here summarizes the distance in miles between each pair of the grove and the processing plant. We've already created the LP model for this problem and also created a graph to analyze it at first. So we can see that the decision variables are how many citrus to ship between each pair of the grove processing plant. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 decision variables, representing number of bushel to ship from each of those nodes, representing the supply node, to each of the processing plant, the defined node. And we're going to minimize the total bushel miles, which is the sum product of our decision variables and the distance between each pair of those nodes. The constraints we had are that for those capacity constraints, we have the bushels of citrus that get shipped into those processing nodes, which are 4, 5, 6, need to be less than or equal to their processing capacity. And for the supply nodes, for the supply node 1, 2, 3, what we have is that what ships out at each supply node need to be equal to the supply at that location. And we formulated this constraint determining this sign being equal here and less than or equal to here because of the total supply and total demand relationship. Okay, so now we're going to implement this model in Excel. So go to your Excel, create a new tab if you want to put it in the same spreadsheet where you had the previous problems. So this is the transportation problem. And what we are going to do is to copy this entire table. So this entire table to Excel. Okay, so to save some time, I'm going to try to see if I can just copy this table directly to my Excel, see if the format will. Okay, for you to follow, you can just pause the video and input those data in your Excel spreadsheet. Make sure you copy those numbers correctly. So now these are the information given. And in addition, we also have the processing capacities and the supplies at each of those nodes. So we have for these are the processing plant, we have the capacities. So for those groves, we have the supplies. The reason I'm leaving one column here and one row here is that I know the supply numbers, the capacity numbers, they will be the right-hand side of my constraint later, okay? And I need to leave space for my left-hand side, which will be a formula that we're going to add in. So now here, my supplies, let's look at, so my supplies are 275, 400, and 300,000. 275, 000, 400, 000, and 300, 000. And for the capacities, the processing capacities, we have 200, 600, and 225. have 200,000, 600,000, and 225,000. Okay, so with this, we get all the information that we have, all the values, numerical values we have in the spreadsheet. And we know that when we create the decision variables, we can take a look. So if we use this graph here, we have one decision variable between each pair. It corresponds to this table here. It's like, okay, we have x14 here, x15 here, x16 here, right? And here we have x24, x25, and x26. Here we have x34, x35, x36. So those are the decision variables that correspond to this table. As a result, in the Excel spreadsheet, we can just create something very similar. So I'm going to just insert, I'm going to insert several rows here. Okay, and then I'm going to copy this table, copy it here, and delete those values, shade them in yellow, make them represent my decision variables, my x14, x34, x36 here. So those are my decision variables. The next step would be to find a cell that calculates our objective function. So we mentioned our objective function is the sum product of the distance and the decision variables. Basically, the sum product of these two tables, okay? And then that's the total distance. So I'm going to just put it here, say the total distance bushel miles. And that's my objective function. And we're going to put the formula there, equals to be a sum product of this array, this table, and this table. Okay, so very simple. Shade it in blue. Okay, so we have our decision variables highlighted. We have our objective function, the formula input, and shaded. Now we're going to look at the constraints. So we have two groups of constraints. One group is for the capacities, the left-hand side, 14 plus 24 plus 34, that's equal to 200. Okay, so let's take a look at the capacity. Okay, so the 14, the 24, the 34, so these ones, sum them together, need to be less than equal to the capacity here. And since this should be related to here, I'm going to actually just move the row. I'm going to insert some rows here. I'm going to insert 2 rows here and shade them and put it here. Okay, and the same for the supplies, because those are related to my decision variables. I'm going to shift them to this table instead of putting them here, leaving them there. So it's the what ship in. Let's do this. So ship in total. Okay, so the shipping total is basically the sum of those values. So that represents the x14, x24, x34. Take the sum of them. That represents all the bushels get shipped into Ocala. So the sum of them should be less than equal to the capacity there. This formula can be copied all the way to here, this column. Click into it to check. Okay, so it's taking the sum of those three values. That's right. So those will be my left-hand side of one group of constraints. I'm going to just shade them in red. And the other ones are the supply. So what ships out from each location need to be equal to the supplies to make sure that we ship out everything. Okay, so ship out so this equals to be the sum of the row here. So this represents that for every grove, what they ship out to the three different plants add up together need to be equal to their supplies. So we ship everything out. Now we're going to copy this formula to the two cells down below it. Click to check. Okay, so it's the sum of these three cells. That's copied correctly, and then we're going to just shade them. Those are the left-hand side. With this, we finished all the design parts, all the spreadsheet parts, and we're going to just maybe add more borders and again some cosmetic work to make it look better. Of course, you can do that later if you want to solve the problem first and decide to work on the cosmetic, make it look better later. Okay, so this one I'm going to use the seek border to represent my decision, my objective function. Okay, so now if you are ready, we're going to go to solver to specify those, first of all, the decision variables. So this entire table, okay, click in the decisions, and then my objective is to minimize the total bushel miles here, and my constraints. So remember, for the constraints, the total supply, the ship out total need to be equal to the supplies. So on the right hand side, to make sure we ship everything out. Again, this is because we have more processing capacities than the supplies. When we determine the relationship between the total supply and the total capacity or total demand, we find out that we have more capacity than we have supplies. So we just want to make sure we ship out everything. Okay, so and for the other constraint, the other group of constraints, the shipping total need to be less than equal to the capacity. So we do not exceed the capacity at any of those processing growth. And don't forget the non-negativity constraint. So if you are using the basic solver, check that box at the bottom of your solver window to make sure that unconstrained variables are non-negative. And or you can do the same thing. So select all the decision variables, make them greater than or equal to 0. Okay, and then we are ready to solve it. Okay, so you can see that the total distance is this value here. And for this problem, if you get different results, but the total bushel mile distance, the objective function value is the same with mine, then you are fine. Remember, we mentioned that there could be alternative solutions. So for this problem, there are alternative solutions. So the solution, so those values, how many bushel to ship between each pair of the grove and plant can be different. But your total bushel miles, which is the minimized total distance, should be the same with mine. Okay. With this, we conclude this modeling.